Alright, hello everybody. This is a quick video just to help you understand how to graph standard form equations and how to use transformations to help you graph those equations. So the first thing that we want to understand is graphing standard form quadratic equations means that we're graphing equations that have an x squared in them. So the most basic form that we can have is y equals x squared. And let's see what happens when we plug some points into there. If I plug in points like 0 squared, again, is going to come up to 0. 1 squared would be 1. 2 squared is 4. And 3 squared is 9. Again, those are just our basic perfect squares. If I plug in -1, remember that -1 times itself is also positive 1. -2 would be -2 times -2 is positive 4. And -3 times -3 is positive 9. So again, negative numbers squared also come out to positives. Which means that you notice from 0, 1, 4, and 9, 0, 1, 4, and 9, we have this point in the middle where it kind of creates what we call sort of a line of symmetry. And our vertex, as we call it, is that 0, 0 point. So if I plot 0, 0 over here on my graph, I'm going to plot 1, 1, and 2, 4. I'm also going to plot -1, 1, and -2, 4. And again, I can go up to 9 for those other 2 points. And you'll see we get a nice parabola, right, curving at the bottom, but not a straight line anymore. We get that curve on our graph. Again, the lowest point being called the vertex, the axis of symmetry being that vertical line right through the vertex. And if you know the nice shortcut, 1, 3, 5, 7, you'll notice that from the vertex, we went right 1 up 1, right 1 up 3, right 1 up 5. So there's kind of a nice little formula to, again, a 1x squared, having just a 1 in front of there, graph. Well, we can use that idea along with some transformations to graph quick and easy parabolas. If a parabola is multiplied, or a quadratic equation is multiplied to where that a value, ax squared here on our screen, if a is positive, then it can either stretch if a is greater than 1, or shrink if a is between 0 and 1. So blue line here would have just been basic x squared. The red line would be something like 2x squared, or the green line might be something more like 1/2 x squared. All of those graphs could also be kind of flipped over, or what we call vertically reflected, if a is negative, it's less than 0. So again, the green line would be something a lot like y equals -1/2 x squared. Again, the blue line would be a simple negative x squared. And the red line might be something more like -2 or -3 x squared. Over here at the right, we also have the transformation of vertically shifting. If we add or subtract on the end of our graph, right, x squared plus a number or minus a number, it's going to take all the points on my graph, again, that blue line being x squared, and I could shift them up if c was something like 2 or 3, or I could shift them down if c was more like -2 or -3. It's going to move my entire graph up or down. It's the exact same curve. If you look carefully, this middle of this curve is the exact same. It's just shifted up or shifted down, including the vertex. The vertex will also move to whatever that c value was. Let's see how that can affect our graph, actually plotting a couple of graphs. So taking a good look at the graph over here at the right, 1/4 x squared means that I'm going to take all of my x squared values, I'm going to take all those y values, those output values, and I'm going to multiply them by 1/4. I'm going to shrink this graph by 1/4. Or my old graph where I said 0, 0, right? 0 squared is still 0 times 1/4 is still 0, is still going to be plotted right there at the origin. But when I plug in 1, 1 squared is 1 times 1/4 is only 1/4. So notice I'm not up at y is 1 anymore. I'm down here at 1/4. Then, when I get 4, right, when x was 2, 2 squared would have been 4, but 4 times 1/4 is just a 1. So we're right here. So I get a graph that looks much wider, right? And again, 1/4 to this side, 1 to this side with that symmetry. I get a graph that's much wider around that axis of symmetry, right around that y-axis. Over here at the left, we have two different things going on. -x squared, again, is going to be that vertical reflection. So we're going to get a parabola that's going to open downwards. and plus 4 is going to be a vertical shift up 4. So now again, I'm going to take that vertex, I'm going to multiply it by -1, so that y value of 0 just became 0 times -1, which is still 0, but I'm going to shift that up 4 units. Where we were at +1 before, again becomes -1, but I'm going to shift that up 4 units. And again, +4 becomes -4, shift that up 4 units. And my parabola, again using that symmetry idea again right around that y-axis, is now looking a lot more like this. Okay? It's going to open downwards, but it's also shifted up 4 units. Using that idea of transformation, we can quickly make graphs out of old graphs. So if y equals x squared, again, is my parent function. It's that initial value, that easiest quadratic that we can plot, right? 1, and 3, and 5. That parabola opening upwards right here. And again, go in the other direction as well. Get that nice x squared graph. Well, now what happens is, when I take those old y values, right, and I subtract 9 from them, right? I take my old vertex of 0, 0, and I subtract 9, it becomes -9, 1 would be -8, 4 would be -4, and 9 turns to 0. So my new vertex is going to be 0, -9. So I'm going to take that all the way down here, where I used to be at 1, right? 1, 1, I'm now at -8. So 1, 1 goes all the way down to -8. Where I used to be at 4, I'm going to go all the way down again to -4. So we get points right here. Oops, I think I'm off there a little bit. Oops, 4 minus 9 should have been -5. That's why. -5 here. So let's move that point. Let's move that one down right here. Down here at -5. And again, where 3 used to go to 9, now it's going to go to 0. Right? These are my old x values. 0, 1, 2, and 3. I'm now at 3, 0. So 3, 0 here, 0 there. I've shifted my entire parabola. Okay? Sorry, that one didn't look very smooth here. Bad idea. Don't just fill it in like this. That's a bad plan. It looks very messy. But you get the idea that it's shifted down 9 units. Let's take a look at that multiplying idea one more time. If I take all of my y values again, my old y values from my parent function, right, from x squared, and I cut them in half, 1/2 of x squared. Remember, these values are all x squared. Well, half of 0 is still 0. I'm still going to be at the origin. But half of 1 is 0.5, half of 2 is 1, and half of 3 is 1.5. My old graph that used to be here is now at 1/2, 2, and at 4.5. And I'm taking those y values. 4.5 is a 2, 9 would have been a 4.5. So I'm going to cut those values in half. 1, 2, 3, 4.5. So notice I'm right below those old black points. And again, I can reflect those over using my symmetry idea to get a nice smooth parabola. Take a second, think about what happens to these points down here. Again, if my old y values were 0 and 1 and 4 and 9, what's going to happen when I multiply x squared, right? Multiply that x squared by -4. I'm going to pause the video now, fill in the numbers, and we'll see what that parabola looks like. So here we go. Again, I took 0, 1, 4, and 9 and multiplied them all by that -4 right here, which gave me 0, -4, -16, and -36. Now, unfortunately, since I was counting by ones on my other graph, I have to continue to count by ones. But notice, again, 0, 0 stayed where it was. What used to be at a 1, right, 1, 1 up here, is now way down here at -4. And unfortunately, -16 and -36 are well off my graph. But you see how narrow that graph looks because we stretched our graph. Right? First we reflected it, so it was going downwards, but then we stretched it out to where it got very narrow and very tall. All right, let's do one more example where we mix a few things in. Again, take a second, pause the video now. How would -3 affect my y-coordinates? And how would a +7 affect them? List off those transformations, and then we'll take a look at the graph and see how that affects both the graph and what we call the domain and range. All right, and we're back. Again, a -3 is going to be a negative, so it's a vertical reflection. We're going to open downwards. A vertical stretch by 3, so notice we're a little narrower, we're a little taller than we were before. Our points are a little farther apart, where we went up 1 and up 3 before. Now I went down 3 and then down another 9. So quite a far distance between those points. And then finally added 7, so everything got shifted up 7. Our new vertex is 0, 7 on our graph, way up here at 7 on the top. And then again, smooth line connected with arrows. And we got a decent looking graph there. Don't forget to label both the x and y axis. Now, talking about the domain and range, notice that left to right, we still get lots of points. We can plug any x value we want into our graph. We're going to get an answer back. We'll get a real number answer back. So our domain is going to be all real numbers, or that R with the double bar there. All real numbers. There's one symbol. All real numbers. I can plug anything I want in. I can square any real number. I can multiply a real number by -3. I can add 7 to a real number. I'll always get an answer. But what you'll notice about our red graph is I'll never get an answer that's greater than 7. The range of my graph is that y is currently less than or equal to 7. I'll never be above 7. So again, hopefully that little reminder of domain and range will also remind you parabolas open either up, where they've got a minimum number, where they're going to open above it, or downwards, where again your range would either be greater than 0, such as for x squared here, greater than or equal to 0, or they could be less than or equal if they're opening down to some constant, some number like 7. All right, I hope that helps you with your parabolas. Good luck transforming your graphs. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day and happy parabolas.